In section 8.8, I'll be going over complex numbers. In this short video, I'll go over some key ideas and examples, but don't forget to log on to Canvas and view the supplemental notes for more samples. Let's begin. We represent the letter I to indicate an imaginary number. I is equal to the square root of -1. And therefore, I squared must be equal to -1. We write our numbers in standard form, which is a plus bi, where a represents the real part and b represents the imaginary part. When it comes to adding and subtracting complex numbers, we think like terms. So think if the term has an I, it's kind of like a variable x. So only like terms can add and subtract together. When it comes to multiplying complex numbers, we'll do normal multiplication techniques such as FOILing. But remember, at the end, we'll replace any I squareds with -1 and then simplify. Next, I want to talk about conjugates. If I'm given z equals a plus bi, the conjugate is denoted by z bar, and that is equal to a minus bi. If I'm given z equals a minus bi, then its conjugate, z bar, is a plus bi. And one more example, if I'm given z equals -a plus bi, then its conjugate, z bar, is -a minus bi. So only that middle sign between the real part and the imaginary part will flip. So if it's positive, it'll become negative, and if it was negative, it will become positive. We need conjugates to help us do this next piece, which is called rationalizing the denominator. In math, we like to write our answers in standard form, so we don't want any i's in the denominator of a fraction. So let's take a look at this example. I have 1 over 5 plus I. We want to rationalize the denominator, meaning remove the I from the denominator so it's in the numerator. And to do that, we multiply top and bottom of our fraction by the conjugate. So in the bottom, I have 5 plus I, so then my conjugate must be 5 minus I. And remember, in math, whatever I do to the bottom of a fraction, I also have to do to the top of the fraction. On top, I'm going to distribute the 1, so I'm just going to be left with 5 minus I. And on the bottom, I will have to FOIL. So f, 5 times 5 is 25. Outside, 5 times -i is minus 5i. Inside, 5 times I, positive 5i. And last, I times -i is minus I squared. And then we can simplify. Nothing to do up top, so that'll come down. Now let's look at the bottom. In the middle, my o and my I term, I have -5i and positive 5i. That's going to cancel, so I'm left with 25 minus I squared. Keep on going with the simplification. Again, nothing to do on top. And then on bottom, I have an I squared, so I'm going to replace my I squared with -1. The minus sign comes down, I'm going to use some parentheses and insert -1 for the I squared. And now I have negative on the bottom, which is going to become a positive. And final answer, I got 5 minus I over 26. Nothing simplifies, but if I want to write this a little prettier, just so it's in the a plus bi format, I can go ahead and remember in math this denominator belongs to both items in the numerator. So that's 5 over 26 minus I over 26. Or if you want to write it one more way, it could be 5 over 26 minus 1 over 26i. Any of those are acceptable.